It's like, imagine you're rolling around in a basin, okay? And you're stable there, you're just fine, but then something kicks you out of the basin and you didn't know that there's a huge hill to roll down after you come out of that basin.
Imagine a universe where everything we thought we knew was about to be turned upside down. In the depths of space, a telescope is unveiling secrets that challenge our very understanding of the cosmos. Join us as we embark on a journey through the lens of the James Webb Space Telescope, a journey that will defy our perceptions of the universe and leave us questioning the very nature of reality. Not only has it captured some of the most fascinating visuals of our universe, but it has also brought forth a myriad of groundbreaking discoveries that have altered our perspective of the universe entirely. As part of its long, arduous journey of mind-blowing findings, the iconic James Webb Telescope has recently uncovered something so incredible that it has the whole scientific community reeling with shock. James Webb has revealed a massive structure that is way older than the universe, raising the intriguing question of how a structure can predate the universe. Sounds impossible, right? To put that in perspective, the universe is estimated to be 13.7 billion years old. However, this brand new discovery is set to change the whole game. Join us as we investigate the latest milestone in the James Webb Telescope's epic space travel and explore how this fresh finding impacts the universe as we know it. The space industry's most potent weapon so far, the James Webb Telescope, has unveiled an age-defying structure older than the universe that has left scientists astonished and space enthusiasts questioning their previous knowledge. But before we talk about that, let's quickly glance over the spectacle that is the James Webb Telescope and what this technological powerhouse has notably achieved so far. Blasted off into orbit on December 25, 2021, James Webb's launch marked decades of strenuous efforts by NASA's brilliant scientists and engineers. In July 2022, the observatory released its first images that captivated the whole world. The Carina Nebula, also known as the Cosmic Cliffs, was one of the first full-color photographs released by NASA. The cloud of gas and dust, which is about 7,500 light-years from Earth, gives birth to new stars. Many of Webb's targets, including the Carina Nebula, were previously unknown to astronomers. However, the observatory's unique ability to see in the infrared spectrum allows it to penetrate dust clouds that might obscure other telescopes. And then, just about 2 months later, James Webb had another breakthrough, an exoplanet.
The largest and most powerful telescope in NASA's history has spotted a new Earth-sized exoplanet.
Exoplanets have only been imaged about 24 times since their discovery in the 1990s. The majority of exoplanets are so distant that they can only be detected when they pass in front of their host stars. In September 2022, Webb's cameras, along with filters and coronagraphs designed to block the central star's light, achieved an unprecedented direct image of an exoplanet with remarkable clarity. The planet, known as HIP 65426b, is a gas giant 6 times the size of Jupiter. The achievement demonstrated James Webb's ability to photograph extremely sensitive images of previously inaccessible objects. Apart from that, Webb also discovered its first exoplanet. The planet known as LHS 475b was caught by the telescope's near-infrared spectrograph in January 2023. The planet is nearly identical in size to Earth and a few hundred degrees warmer. The near-infrared spectrograph was also used to generate a transmission spectrum in order to study the exoplanet's molecule range. What else? In October 2022, the James Webb Space Telescope released the clearest view of Neptune and its rings in decades. Some of these rings haven't been seen since 1989, and others have never been seen at all. The photo was taken with Webb's near-infrared camera and shows the planet's bright rings as well as fainter dust bands. The dust bands are visible as fuzzy particles between the brighter ice-dominated rings. Within the same month, the James Webb Space Telescope snapped the pillars of creation with greater detail and clarity, revealing hundreds of previously invisible stars. The picture not only affirms Webb's capabilities as an infrared telescope, but also aids in our understanding of how stars form. It was photographed and popularized as the vast clouds of gas and dust by the Hubble Space Telescope in 1995. Webb also captured WR-140, a Wolf-Rayet star, in October 2022. The star is a binary or dust-forming double-star system. Notably, the photograph depicts the star as being surrounded by at least 17 concentric rings, which scientists believe to be dust shells. Each ring was formed when the two stars collided and their stellar winds interacted. Stellar winds are streams of fast-flowing charged particle streams emitted by stars. The even spacing between the shells suggests the dust formation events occur once every 8 years. The observatory boasts numerous cosmic accomplishments. Fast forward to 2023, when astronomers using the James Webb Space Telescope made a remarkable discovery: 6 colossal ancient galaxies, often referred to as universe breakers. The existence of these galaxies has the potential to challenge the current theories of cosmology. These objects originate from a period when the universe was only 3% of its present age and are significantly larger than what was previously believed to be possible for galaxies during this early stage after the Big Bang. It has challenged scientists' comprehension of the process by which the earliest galaxies were formed. Joel Leja, an assistant professor of astronomy and astrophysics at Penn State University and a study co-author, says, "These objects are way more massive than anyone expected. We expected only to find tiny, young, baby galaxies at this point in time, but we've discovered galaxies as mature as our own in what was previously understood to be the dawn of the universe." Dr. Erica Nelson from the University of Colorado Boulder and a co-author discovered a set of bright and red fuzzy dots while examining images from the initial dataset of NASA's James Webb Space Telescope. Equipped with infrared sensing instruments, the telescope can detect light emitted by the most ancient stars and galaxies. In astronomy, the color red indicates the age of an object. As light from distant objects travels through the expanding universe, it undergoes a transformation known as red shifting. This means that the light waves get stretched out, causing them to shift toward the red end of the spectrum. Based on this, scientists estimate that these galaxies are approximately 13.5 billion years old, appearing around 500 to 700 million years after the Big Bang. James Webb has observed galaxies that are not the oldest. In the previous year, scientists discovered 4 galaxies that existed approximately 350 million years after the Big Bang, but those were extremely smaller. The calculations indicate that the most recent galaxies contain a mass equivalent of tens to hundreds of billions of stars the size of the Sun, making them comparable to the Milky Way. "It's bananas," said Nelson. "These galaxies should not have had time to form." To account for the presence of these extremely large galaxies at the early stages of the universe, scientists need to reconsider certain fundamental principles of cosmology, or reevaluate their understanding of how the first galaxies were formed from small collections of stars and dust. It turns out we found something so unexpected it actually creates problems for science, said Leja. It calls the whole picture of early galaxy formation into question. Previously established models proposed that following a phase of swift expansion, the universe underwent a cooling process lasting several hundred million years, during which gas was able to come together and collapse, leading to the formation of the first stars and galaxies. This epoch is commonly referred to as the Dark Ages. Dr. Emma Chapman, an astrophysicist at the University of Nottingham, commented that the discovery of such massive galaxies so soon after the Big Bang suggests that the Dark Ages may not have been so dark after all, and that the universe may have been awash with star formation far earlier than we thought. Chapman further said, "With the pace that JWST has been upturning theories and revolutionizing whole fields, it wouldn't surprise me if it were true." The perplexing galaxies seen in these images were captured by Webb's near-infrared camera, NIRCam, as part of the Cosmic Evolution Early Release Science (CEERS) program. The James Webb Telescope has so far revealed hundreds of ancient galaxies that may be among the universe's earliest members. These very young galaxies displayed complex structures and clusters of star formation as early as 600 million years after the Big Bang, as reported in a recent study. This study is part of the JWST Advanced Deep Extragalactic Survey, JADES, an international collaboration that collected a month's worth of observations from 2 patches in the sky. Within these observed regions, over 700 newly discovered young galaxies were identified. These galaxies offer valuable insights into the formation of the first galaxies and stars in the early universe and contribute to our understanding of the rich catalog of elements observed in the universe today. In a metaphorical sense, these galaxies represent the first 5 minutes of the universe if its entire history were condensed into a 2-hour movie. They mark the early stages of element creation and the complexity we observe in the universe today. Previously, only the brightest examples of early galaxies were visible, but the James Webb Telescope is now allowing scientists to explore more common and everyday galaxies in the turbulent young universe. The chaotic process of star formation in these early galaxies contributed to intense recent star formation. Moreover, these early galaxies played a crucial role in cosmic reionization by efficiently producing ultraviolet photons necessary for this process. Hot, massive stars within these galaxies ionize the gas, influencing cosmic evolution. What do you think of these latest findings? Let us know your thoughts in the comments below. If you like this video, give it a big thumbs up, subscribe to our channel, and press the bell icon so you won't miss our next fun video.